Yo, what's going on there, Skulls? Hope you guys are all doing well. And let's go ahead and check out these two distributing radical problems here. All right, so first right here, we have the square root of 11 times the quantity 5 minus radical 2. So what we first want to do is go ahead and distribute this square root of 11. Okay, so I'm going to go ahead and distribute that.
Oh.
So square root of 11 times 5 is 5 radical 11. Okay, and the way you do that is you always put your constant, your coefficient up in front, and then our radical behind it. And then the square root of 11 times square root of 2, since they're both radicals, we can go ahead and actually multiply those and then put them under one radical right there. So minus the square root of 22. So now, this is how we know if we're done or not, okay? Can we simplify the square root of 11, and can we simplify the square root of 22? Well, the answer to that is no. You can't simplify either one of them because there's no perfect square that can go in either one of them. You say, what are our perfect squares, right? So if you think about it, our perfect squares are 2 squares, 4. Does 4 go into 11 or 22? No. 3 squared, 9. Can 9 go into any of these? No. Watch out. 4 squared, 16, and it keeps going on, right? So 25, 36, 49, and so forth. So this is how you know if you're done. Do any of these perfect score numbers, can those divide into any one of these? If the answer is no, that means you're done. So this is a pretty straightforward, just a distributive property right there, all right? All right, so now we're going on to this little hairy guy. All right, and again, we have 7 times the quantity radical 54 minus a radical 24. So now we want to go ahead and first distribute that 7. So 7 times radical 54 is just simply 7 radical 54, okay? And then 7 times a negative square root of 24 is a minus 7 times square root of 24, okay? So now let's go ahead and ask ourselves that same question. Do any of these right here, perfect squares, go into 54? Well, yeah, right, what's that? 9 and 6, right? 9 times 6 is square root of 54, so check this out. So I'm going to simplify this, or I'm going to break it down. I'm going to rewrite this as 7 times the square root of 9 times the square root of 6. Okay, because this has to be equivalent to the square root of 54, and it is, right? 9 times 6 is 54, okay? So let's leave that alone. Minus 7, same thing with 24. Well, here 4 goes into 24, so we can rewrite that as the square root of 4 times the square root of 6. Okay, now let's go ahead and simplify. Okay, this is 7 times radical 9, which is 3, right? So this is 7 times 3. Okay, so that's 21 times radical 6, right? Again, one more time. 7 times, this is just 3 right here. Square root of 9 is 3. 7 times 3 is 21. Minus, this right here is 2. Square root of 4 is 2. So 7 times 2 is 14 times radical 6. All right? And one of our rules now in adding and subtracting radicals is the radical must be exactly the same in order to combine these. And so it is, right? So 21 times square root of 6 minus 14 times square root of 6, that is just going to be 7 times the square root of 6. And that's it.